We're going to go over electric flux. Electric flux is the electric field passing through a surface area. The equation for electric flux which has this funny looking I symbol is E, which is electric field, A, which is area, cosine theta. So let's say we have a plane in 3D. It's a 3D plane. And we have this imaginary line going through the normal of the plane. Normal is a perpendicular line through a plane. And we have electric field lines penetrating the plane. Theta is the angle between the normal, or the perpendicular line to the plane, and the electric field lines. So here's theta right here. I'm going to draw the plane again. And A, the area, is the area of the plane. And E is the strength of the electric field. Applying this equation to the plane gives you what the electric flux of the plane is. Now let's say we have 2 point charges. We have the negative point charge right here and a positive point charge right here. And they're surrounded by these two spheres. So we're going to have field lines going from the positive to the negative. We went over this in a previous section. Field lines leave the positive and field lines enter negative. So, we have a few principles we need to go over. The first is that flux entering the volume, or the sphere, is negative. Electric flux. So the flux of the sphere is negative, because electric fields are passing into the volume. It's the opposite for flux leaving the volume. Flux leaving the volume is positive. So in the situation of the positive charge, flux is positive because flux is leaving the sphere. And our third principle is that flux is zero unless a charge originates within a volume. And this is the most important principle of this section, because it's going to be used for our next section. So we're going to talk about it now. Say we have 2 point charges, a positive and a negative like before. And we have a sphere right here. So we're going to draw these field lines again. So as you notice, there's no charge within the sphere, and all the flux that goes into the sphere also goes out, positive and negative, so they add together. When it goes in here, it's negative, so we have a negative flux, but it comes out here, so we have a positive flux. What goes in equals what goes out, so flux becomes 0, and that is because there is no charge inside the volume.